Alright, this is a continuation of the 3-1 notes, so you can just continue right where you left off. But this is example 6. Previously we talked about solving systems using two methods, graphing and elimination. Now today we're going to talk about the third method, which is substitution, but we're also going to practice a couple of word problems. Let's get started. When we're using substitution, it differs from elimination because what we're going to do first is isolate a variable. You can choose any variable you like. It can be x or it can be y, and it can be in the first equation or it can be in the second equation, but typically one variable will stand out. It's the one that usually has a 1 in front of it, or the one that's easiest to solve for, the easiest one to isolate. That's the one I would try to get alone. You can work with some of these others, but you're going to create fractions. Usually students don't like that. Let's see what happens when I try to isolate this x. I'm going to add 7y to both sides, and I get x equals 7y plus 11. From there, what I'm going to do, this is called substitution because I'm going to actually substitute x into the other equation. Substitute what we found into the other equation. So what that means, if x is equal to 7y plus 11, where I see x in the second equation, I can replace it with just that. I can replace x with 7y plus 11. And everything else I'm just going to bring down. I'm going to bring down the 5 plus 4y equals negative 23. And with that being said, let's go ahead and solve this bad boy for y. So first distribute. And then solve how you know how. So I'm going to combine like terms. Subtract 55 on both sides. And divide by 39. So y equals, that's a y, equals negative 2. So with that being said, we have now solved for that variable. So solve for variable 1, to get variable number 2, you have to plug it in to either one of these original equations, or you could even plug it into this one that you already solved for. That might be handy. Plug in what you got on step 3 and figure out the other coordinate. So I have y equals negative 2. So what I'm going to do, I'm going to just plug it into what I have here. X equals 7 times y plus 11. And instead of having y, I'm going to replace y with negative 2. And I'm doing that because we already solved for that value. So negative 14 plus 11. So that is negative 3. Don't mix these up. Just because you solved this second doesn't mean that it's the second coordinate that is in fact your x value. Alright, why don't you go ahead and try this next one. Pause the video here and decide what variable to solve for, and then try it on your own. I got negative 5, 3. Did you get the same thing? I hope so. If not, make sure to ask questions. We're going to try a couple of word problems. 2 I'm going to do with you, and then 1 I'm going to have you try on your own. This first one says Alejandro has a computer support business. He estimates that the cost to run his business can be represented by this equation. Y equals 48x plus 500. And whenever you have word problems, it's a good idea to try to figure out what those equations represent. This one is representing the cost to run that business. And then it says he also estimates that his income can be represented by this other equation. So I just want to label what these represent. The first one represents the cost to run his business, and then the second one represents the income to run his business. Y equals 65x minus 145. Alright, Alejandro needs, how many customers will Alejandro need in order to break even? What will his profit be if he has 60 customers? So in order to break even, they're asking you, when will these two be equal to each other, the cost and the income? When will the cost and income be equal? Well, lucky for us, we just learned about substitution. And one thing we also learned is that if a variable is solved for, we can just replace it in the other equation. So it is already set up nicely for substitution. But mind you, if I just multiply it through by a negative, I could use elimination to eliminate the y's. So it's really up to you what you feel more comfortable with. I'm going to use substitution just because we just talked about it. I'm going to isolate y, which it's already isolated. So what I'm going to do is replace y in the other equation. So I'm replacing the green y with 48x equals 500. Sorry, plus 500 equals plus 500 on 50 equals 65x minus 145. Let's go ahead and solve this. I like to move the smaller of the x's. So 500 equals 17x minus 145, and add 145 to both sides. So I'd get 645 equals 17x. And then, of course, divide by 17. And when I divide this by 17, I get a funky decimal. I get like 38.97. You have to think about these word problems. They're very specific. And I would think, does that answer make sense in context of my problem? It turns out to be 37.97. Well, I'm not going to have, when x represents the number of people or the number of customers, that answer doesn't make sense. So I'm going to go ahead and approximate to 38. So it would make sense for him to break even at 38 customers. Won't be exactly right, but that's as close as it's going to get, because we're not going to chop someone's pinky finger out to make this come true. Part B says, what will his profit be if he has 60 customers? Well, first you have to know what profit means. That means how much will he actually make, which would be what he makes, his income minus the cost. So we have to plug in 60 in both equations to start. So let's see. Let's see what he makes. What will the cost be if there's 60 people? 48 times 60 plus 500. And I worked that out and I got 3,380. That would be the cost of serving 60 people. And so let's find the cost or the income from serving 60 people. So I'm plugging 60 into the second equation. So for that, I got 3,755. So the 3,755 represents the income from serving that many people, but the 3,380 represents the cost that of his shop to serve that many people. So to find the profit, you have to subtract these two. 3,755 minus 380, and it equals 375. So he would make a profit of $375 if he served 60 people. Not sure how I would feel about that if I was him. That's a lot of hard work. Let's go ahead and try example 8. So you're running a concession stand on this one. You're selling hot dogs and sodas. So what I would do is go ahead and write out my variables and decide what they represent. So H is going to be for the number of hot dogs. This is called defining your variable. Let's define the variables. H would represent the number of hot dogs, and S would represent the number of sodas. Number of sodas. So it says each hot dog costs $1.50, soda costs 50 cents. At the end of the night, you made a total of $78.50. So let's write our first equation. $1.50 for each hot dog, and then plus 50 cents for each soda, for a total of $78.50. The next equation isn't quite as intuitive to figure out, but it says you sold a total of 87 hot dogs and sodas combined. So the number of hot dogs plus the number of sodas combined that you sold was equal to a total of 87. So it says you must report the number of hot dogs and the number of sodas sold. How many hot dogs were sold and how many sodas were sold. So in this setup, I could either do substitution or elimination. That would be up to you to decide, but I'm going to go ahead and go for elimination. Anytime it's in standard form, this isn't really too difficult because I can multiply by -2. And in doing that, that's going to help me cancel out the sodas. So I would have -3H minus 1S equals -157. And then my second equation, H, or I can put 1H plus 1S equals 87. And let's see what those turn out to be with elimination. -2H equals -70. So I would divide both sides by -2 and I'd get H equals 35. So think about what that means in the context of your word problem is you sold 35 hot dogs. So how would I figure out the number of sodas? Plug it back into one of these original equations. I think it's a little bit easier to plug into the red one here. I'm going to say 35 plus S equals 87. So of course just subtract 35 from both sides and I would get 52 sodas. So make sure your answers make sense in the context of the word problem. Sold 35 hot dogs and 52 sodas. Alright, take a couple of seconds and pause the video and try this one out on your own and see what you get. Alright, I got soft tacos cost $1.25 each and burritos cost $2.50 each. Hopefully you got the same thing. Alright, let me know if you have any questions. Bye.